Hello and good day, Algebra. We're going over the last of the operations with polynomials today. We've covered addition and subtraction. We've done the multiplication, several objectives on multiplying them. And so last up is division. And the good news is, like with multiplication, you've done this before. Okay, you've done this before. If you think back to CO11, which is where we divided exponent expressions by the same base, that's essentially what we're doing here. Okay, who can remind us what the rule is for dividing expressions by the same base, such as 10x to the fifth divided by 5x squared? What do we do with the coefficients? What do we do with the exponents? Ethan?
Coefficients are simplified.
Coefficients are simplified, so we treat them like a fraction, right? 10 fifths, or 10 divided by 5, equals 2. And what about the powers, Ethan? Subtract them. Okay, you have 5 x's up in the numerator, you have 2 x's down in the denominator. All said and done, you've got 3 x's in the numerator. And the reason why this works, it's been a while, it's been 39 objectives since CO11, is that in standard form, we've got 5 x's in our numerator and 2 x's in the denominator. Right? And anything divided by itself is what?
47.
No. Anything divided by itself is what? 1. So all of these pairs of x's, x divided by x, they essentially cancel out. Right? And if those 2 x's from your denominator cancel out with 2 in your numerator, Garrison, you're left with 3 in your numerator. So we get 2x cubed. And what was the trick to remembering where those x's go, numerator or denominator?
If it's positive, it's up.
Not necessarily. It was something to do with that, I suppose. Helen?
Whichever one has a more amount of higher powers.
Right. Where we've got more to start with, that's where the leftovers are going to be. Okay? Something like 45x to the 11th over 9x to the 7th. Who's confident in what they think this simplifies to equal? Eli. 5x to the 4th. 45 divided by 9 is 5. 11 minus 7. Those 7 x's cancel out with 7 up top. We're left with 4 of them in the numerator. Okay? What happens when your coefficients don't divide evenly, though? Such as 15x to the 5th over 12x to the 4th. Well, Dinsky?
Isn't it like going to be a fraction?
Yeah, you simplify it like you would a fraction. What's 15 twelfths simplified to be? Izzy? 5 fourths. So 5 is in your numerator, 4 is in your denominator. How many x's and where are they? Cole?
There's 1x.
1x where?
Behind it.
Top or bottom?
Oh, both. Bottom. Oh, bottom. My bad.
Top. Right? Because we have more x's there to start with. These 4 x's will cancel out with 4 of those, leaving you with just 1. Okay? In the numerator. Lastly, 7x squared over 7x cubed. Our coefficients, what happens if they're the exact same? They cancel out. Colin, what's our final answer here?
I was asking about a question.
Save it for just a second. Eli.
1x.
Where? Numerator or denominator? Denominator. Since that x is in the denominator, we still have to have a numerator, right, to show that there's a denominator. What is in our numerator? Oh, I already wrote it. It's a 1, right? If everything cancels out, then it becomes a 1. And in expanded form, we can see this 7 times x over 7 times x times x times x. The 7's cancel out. That pair of x's cancels out. That pair of x's cancels out. There's only 1 x remaining. It's in the denominator. To show that, we have to have a numerator of 1. Don't put 0, right? Because it's not 0, it's a 1. Colin, was your question?
So for the third one,
Yeah.
could it technically be 5 fourths x?
Yes, if you wanted to write it as 5 fourths x, such as like this, okay, that would work. It's better to write it in this case with the x in the numerator, just so I'm not confused. Say, do they need to put that in the numerator or the denominator, right? But that would be acceptable as well. Nick.
For the last one, the fourth one, when you do
1x.
You couldn't put 1x because there's a difference. If you put 1x compared to 1 over x, let's say that x equals 5. 1 times 5 is different than 1/5, isn't it?
Yeah.
Right? So they're not the same. You need to show the x's in the denominator. So you need to be 1 over x. Right? 1 over x. All right, questions on CO11. If you understand CO11, you should understand CO50 pretty well as well. Oh wait, okay. Whatever. Yeah, Caitlin.
For the last one, could you put x to the negative 1?
So x to the negative first means the same as 1 over x. However, a negative exponent isn't considered simplest form. Okay, so then you should move that down to the denominator and make it positive. Okay, they're equivalent expressions, but they're not. X to the negative first isn't considered simple. Anything else? These are great questions to ask.
Can we do the first one?
Yes.
Great. I think I know what that much is.
The first one, we're dividing. Why is that still there? Cool.
Yeah, there you go.
15x plus 10 divided by 5. Because that expression is in parentheses, we're dividing the whole thing by 5. So we're actually kind of using a version of the distributive property here also. Okay? 15x plus 10 divided by 5, the whole thing, means we're taking 15x divided by 5 plus 10 divided by 5. We're, in a sense, distributing that 5 into each of them and dividing each term in the expression by 5, just like we would if we were multiplying. We'd multiply each term in the parentheses by 5. We're kind of doing the same thing here. What's 15x divided by 5? Nick, what? 3x? And what's 10 divided by 5? 2. So our answer is 3x plus 2.
That easy?
Right.
Can we do like the last one?
Next one, 24x squared minus 18x plus 8 divided by 2, the whole thing. It's important that this is in parentheses, right? Because without parentheses, according to order of operations, you'd only be dividing, in that case, 8 divided by 2. But with the parentheses, it groups all those terms together as one expression. We're dividing everything by 2, so we're essentially distributing in 24x squared divided by 2 minus 18x divided by 2 plus 8 divided by 2. And what do we get? 24x squared divided by 2. Andrea? 12x squared. Negative 18x divided by 2.
Negative.
Ryan? Bad time to stretch. Negative 18x divided by 2. Negative 9.
X.
Negative 9x.
I know what.
Okay. And 8 divided by 2. Jocelyn? Plus 4. Okay. So 12x squared minus 9x plus 4. You know this is minus 9x here because it's negative 18x in the original expression. Half that would be negative 9. Initial questions? Okay. Find one that's fun. Find one anywhere on the objective that you want to do together, so we can knock it out. Cole?
Can we do the next page?
Anywhere. Go ahead.
The next page, the
Sure.
last row, the one on the left.
So first one, last row.
Right there.
That looks like a fun one. 26x to the 11th plus 12x to the 8th minus x to the 5th minus 34x squared, all divided by 4x cubed. Okay? The process is the exact same as we did on the front page. We're going to take each term and we're dividing everything by 4x cubed. Right? And once you do that, once you kind of break it up into what's actually happening, it's CO11 exactly. 26x to the 11th divided by 4x cubed. Who's confident? Treat those coefficients as a fraction.
Oh, I thought we always in here.
Subtract the powers. Chase?
It's 6.5 x to the 8.
6.5x to the 8th is the value. However, we want to write it as a fraction. So what's 6.5 as an improper fraction? If we just simplified 26/4. 13 halves,
Yeah.
right? I wrote this kind of big here. I'm going to put the answer up on top here. 13 halves and x to the 8th in the numerator. Okay. On the test, don't put a decimal. Decimals are kind of frowned upon now that you're in algebra, heading into geometry, heading into algebra 2. 6.5 isn't the worst decimal in the world to use because it does end. It's a pretty common one. But generally, your answers should be in fraction form. Okay, so just know that going forward. 12x to the 8th divided by 4x cubed. Who's confident? Maddie.
Oh, I had a separate question.
Go ahead.
How did you get the 4x?
It's what I'm dividing the whole expression by.
Wait, what?
We're on the second page.
Oh, this one. Yeah, I was on the wrong.
Yes, that would be confusing. I understand now. Okay. 12x to the 8th divided by 4x cubed. Kristen. 3x to the 5th. Right? 12 and 4 divide evenly to be 3. Subtract the powers. We have 5 more x's up on top. Negative x to the 5th divided by 4x cubed. Colin?
Minus 1/4 x squared.
Yep, and we would write that as x squared over 4. If you want to put the 1 in front of the x squared, then you could. But x squared over 4, we have 2 remaining x's in the numerator. And lastly, negative 34x squared divided by 4x cubed. Treat those coefficients as a fraction, subtract the powers. Where are the x's? How many more, Caitlin?
Negative 17 halves.
And what about the x's?
2x. The x is by the 2.
And 1 or how many of them?
Just 1.
Just 1. Yep, good. We have 3 x's in the denominator, 2 up top. Those 2 will cancel out with 2 in the denominator, leaving us with just 1. And so 17 over 2x is our answer. That's about as complicated as it's going to get, probably. So if you understand this one, then you're in really good shape. Oh, look at that. The time for review is foil crab claw box. It's like it was meant to be. Meant to
Well,
be.
hopefully we have like 4 days.
Well, 2 of them are foil crab claw box. Maddie, do you have a question?
I'm just kind of confused.
Yeah, let's go over one. Or do you have a question on this
Can
one that we
you
can?
Can you do the one page up and then I think it's the like second to last question?
What does it start with?
10x.
That one. I don't really see that.
What does it start with?
10x to the 5th.
10x to the 5th. 10x to the
I
5th.
have 2 that have
Oh,
time to
that one was for the box.
Oh. Okay.
So that one was meant for this one.
Oh yeah, remember the orders of these pages got a little bit messed up, so you might have to flip a page to get to the second page of this one. Okay, or reorganize them in your binder. Yeah. 49 to 50 for some reason got kind of mixed together. So
That makes more sense.
yes. Good. Anything else? No others you want to go over? Will?
16x to 10.
There. Okay. 16x to the 10th minus 12x to the 7th plus 4x, 14x to the 6th, all divided by 8x to the 4th. So again, we're taking each term individually and dividing everything by 8x to the 4th. Okay? Cool. What do we get for that first one? 16x to the 10th
You get,
divided by 8x to the 4th.
You get 2x to the 6.
Excellent.
Yeah.
16 divided by 8 equals 2. Divides evenly. And then 10 minus 4 equals 6. Those 6 x's are still in the numerator. Next one. Will, you want to
I'll do it.
give it a shot?
Would it be negative 3 halves?
Negative 3 over 2. Yep. And do we have any x's, and where are they?
X to the third for the numerator.
X to the third in the numerator. Excellent job. Okay. And lastly, 14x to the sixth divided by 8x to the fourth. Maddie?
Would that be 7? Over. Wait, wouldn't it be 7 over 4?
7/4. Yep. And how many x's, and where are they?
2 x's on the numerator.
Excellent job. Excellent job. Exactly. 2x to the sixth minus 3x cubed over 2 plus 7x squared over 4. Nathan?
Can you do it above it?
Sure. Hopefully you're finding this is, especially with the recall of CO11, is less intimidating than you originally thought, perhaps. The operation of division can be kind of scary. It usually comes with a lot of rules, think like dividing fractions, things like that. But with CO11 in your back pocket, it is a big help. 28x to the fifth, is that what you wanted? Okay. 20x to the fifth plus 18x cubed minus 12x squared. We're dividing everything by 4x cubed. And what makes this one tricky?
Not knowledge, just do it.
Oh, okay. So it's 20x to the fifth divided by 4x cubed. Cool.
It would be 7 to the second. 7x to the second.
7x squared, 28 divided by 4 divides evenly. And then 2 more x's in the numerator. Next one. Nick?
I just have a question.
Yeah.
So on the 18 over 18x to the third, 4x to the third, can it be simplified a little bit more to like 9 seconds?
That's exactly what you should do. Yes. 18 fourths simplifies to be 9 halves. And what about the x's? How many and where are they?
Up top, just one. Just add one. X.
It's just that, because all cancel.
We don't have any x's left, right? Anything divided by itself equals 1. X cubed divided by x cubed, or 3 pairs of x's all divided by themselves, they all cancel out. We're left with 1. Don't put an x there, because that would mean that you've got 1 x left. You don't. They're all gone. Okay? So it would just be 9 over 2. Right? They cancel out. And the last one, 12 over 4, and then x squared divided by x cubed. Will?
Would that be negative 3x?
And where's that x?
On the denominator.
Denominator. So we minus 3 over x. Minus 3 over x. Now, as far as standard form goes, this is in standard form, even though our constant, that 9 halves, isn't last. Why would that be? Why would this be considered standard form, even though our last term has an x? Our constant, we always said that comes last, but why doesn't it in this case? Extension question, what we call this one. Colin?
Has the x in it.
Yeah, technically, if we have that x in the numerator, what would the exponent be?
Oh, negative 1.
Negative 1. This goes back, I think it was Caitlin that asked earlier, maybe it was Maddie, somewhere there. But that negative power, if we wrote this with our x in the numerator, it would be a negative 1, which is less than a constant, because that has an exponent of 0, right? This is 9x to the 0, because there are x is there. Negative 1 is less than that, so our greatest to least power order, that's why this term comes last, even though we don't write it as a negative 1. It's not in simple form, it still technically does. Okay? This is due on Tuesday, CO50 due on Tuesday. Your math packet, if you want to check it over, today's the last day to turn that in. Otherwise, that'll be due on Wednesday. Even though it says Tuesday, I forgot we didn't have school on Monday, and so it'll be due on Wednesday.
Don't forget to.
Yes, that's how you math.
Don't forget to like and subscribe. Who said bye?